These are the examples for Algebra 2A, Credit 2, Lesson 3.1. And in Lesson 3.1, before we jump into the examples for problems 1 and 2, the main thing that we're introducing in this lesson is the concept of imaginary numbers. Well, that may sound like a made-up topic. It actually has applications in the field of electrical engineering. I looked that up a while back, and there's probably some other applications too, maybe, but for sure in electrical engineering. And so where imaginary numbers come from, before we jump into the example, if I said to you, what's the square root of 1? You would say 1, because 1 times 1 is 1. However, if I said, what's the square root of negative 1? What's often the answer right away is negative 1, but that's not the case, because negative 1 times negative 1 is positive 1. And there might be some other guesses, but what we come to realize is that the square root of negative 1 has no real solution. And if you listen to that answer, no real solution, you can see there's kind of a qualifier in there. It doesn't just say no solution. We say there's no real solution or no real number solution. And so this is where the concept of imaginary numbers comes in. And so what we're going to use to represent the square root of negative 1 is I. And so wherever we see a square root of negative 1, or wherever we can create a square root of negative 1 through factoring, we're going to substitute in I. All right, so let's take a look how we simplify the square root of negative 300, which will serve as our example for problems 1 and 2. So the first thing you're going to do is factor out a negative 1. So factoring out a 1 doesn't change anything. We still have the 300, because 300 times 1 is 300. But factoring out the negative leaves the number, the 300, under the radical as a positive number. And so, again, wherever we see square root of negative 1, we're going to substitute I. And so we've dealt with the imaginary number part of that. So our answer would be I times the square root of 300. However, we can simplify square root of 300. Now, if 300 is a pretty big number, and what you're going to need is all the factor pairs of 300. Now, that can be Googled. If you type in list of factor pairs of 300, so you want to make sure you do type in the word list and also factor pairs, so that list them as pairs versus just listing them out in numerical order. So these are all the factor pairs of 300. You can also do this with a calculator or mentally, and it's not maybe as hard as you might think. So 1 in 300, every number has 1 in itself as a factor, so that's almost a freebie. And then you start dividing numbers, maybe using a calculator. 300 divided by 2 is 150. 300 divided by 3 is 100. 300 divided by 4 is 75. So we have these factor pairs. 300 divided by 5 is 60, so 5 and 60. 300 divided by 6 is 50, so we have 6 and 50. Now, if you divide 300 by 7, you'll get a decimal. So we know 7 is not a factor. And the same thing also for 8 and 9. 300 divided by 10 is 30, so 10 and 30 are factor as a factor pair. 300 divided by 11 gives us a decimal. 300 divided by 12 gives us 25, so 12 and 25 are a factor pair. You might say, when's this going to end? Well, sooner than you think. We're almost there. 300 divided by 13 or 14 will give us a decimal, so we know 13 and 14 are not factors. 300 divided by 15 is 20, so 15 times 20 is another factor pair. Now, if we divide 300 by 16, 17, 18, and 19, we'll get a decimal. And so we know those are not factors of 300. And then we get to 20. However, 20 we already know is a factor. So as soon as you get to a number that you have over here on the right, that you already know is a factor, you can stop. You know that you've found all the factors. So you can Google it, but if you want to challenge yourself with these problems, I would maybe try and do it like this, and then maybe check your answers using Google. All right, so now what we're going to do is look at our list of factor pairs here and ask ourselves, which of these factors are perfect squares? And we have our, remember, perfect square is a number like 4 The square root of 4 is 2 because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6, etc. 7 times 7, 8 times 8, 9 times 9, 10 times 10. And so these are all the perfect squares up to 100. And for the work that you're going to do, this is all you're going to need. You might want to write these down because it will help you out when you're doing problems 1 and 2. All right, so what perfect squares do we see here? Well, we see that 1 is on our list of factors. 4 is also there. 9 is not. 16 is not. 25 is there. 36, 49 are not. 64, 81, 100 is there. So now once you've identified all the perfect square factors, look at well, in this case, we have 4 of them, and look for the factor pair that has the largest perfect square. So there's 1, 4, 25, and 100. 100 is the largest, so we're going to take that pair in order to simplify it. So we're going to break out 300, or square root of 300, to square root of 100 times square root of 3. Notice how we write the number that's the perfect square first. The square root of 100 is 10. And since we normally would write the numerical part before the imaginary part, we have 10i times the square root of 3, or 10i radical 3. So that's how you're going to do problems 1 and 2. For problem 3, we're solving an equation, and we're going to have an imaginary solution. So let's take a look at an example for that. So our example for number 3, we have x squared plus 18 equals 3. And let's go ahead and solve this. It looks like we have 2 steps to solve. We have to eliminate the 18 and also eliminate the exponent. So we're focused on that left side because that's where the 18 and the exponent are. First step is to deal with addition and subtraction. The inverse or opposite of adding 18 is to subtract 18. The 18s cancel, and 3 minus 18 is negative 15. So remember, you can use a calculator for this, but reminding us of our rules, the signs are different, so we subtract 18 minus 3 is 15, and since the larger number is negative, our answer is negative. Finally, to get rid of an exponent of 2, the opposite of raising to the power of 2, we sometimes call that squaring a number or a term. The opposite of squaring is to take the square root, and so we're going to square root both sides. Actually, that 2, we don't typically write it, so we'll just leave that off. So the square root and the exponent cancel out. And here, a couple things. Whenever we solve taking a square root, we put a plus and minus in front of our answer. Since we're taking the square root of a negative number, we're going to factor out the negative 1. And again, factoring out a negative 1 just makes the number underneath the radical positive. Because again, factoring out a 1, just like multiplying by 1, doesn't change the value of the number. And finally, wherever we see square root of negative 1, we substitute the I. And so our final answer is plus or minus I radical 15. All right, so that is our example for number 3. So that is number 3. All right, now taking a look at an example for number 4, let's go ahead and do that. So we have 2x squared minus 7 equals 25. So in this one, we have 3 steps. We have to get rid of the minus 7, the 2, and then the exponent. So our first step is to the opposite of subtracting 7 is to add 7 to both sides. The 7's cancel, and we bring down the 2x squared. 25 plus 7 is 32. X squared is being multiplied by 2, so we divide 2 to both sides. The 2's cancel, and 32 divided by 2 is 16. Our final step, as we mentioned in the last example, the opposite of squaring or raising to the second power is to take the second root or square root of both sides. The square root and the square or the exponent cancel out. And then the square root of 16 is 4 because 4 times 4 is 16. And don't forget, whenever we solve by taking a square root, we put that plus or minus in there. By the way, why do we put a plus or minus in there? Because 2 answers will satisfy this equation. We'll be successful in solving it. So positive 4, 4 squared, 4 times 4 is 16. but also negative 4 squared. Negative 4 times negative 4, because remember, a negative times a negative is a positive. That is also 16. And so that's why whenever we solve by taking a square root, we put a plus or minus in front of the answer, because the answer is both positive 4 and negative 4. All right. Notice, by the way, this did not turn out to have an imaginary solution. We have one of those in there just to remind us that, not every time we square root, we're going to have an imaginary solution. We divide it, we end up with a positive number. So it's just our answer again, plus or minus 4. All right. Finally, our last example for problems, and this example will help you out with problems 5 and 6. We're going to be simplifying an expression, and let's go ahead and do this one, 6i radical 7 squared. Okay, so everything in the parentheses is being multiplied. So 6i radical 7 means 6 times I times the square root of 7. So what we can do is distribute this exponent to each term, or well, each item, we should say, this is all one term, inside the parentheses. So we have 6 squared, I squared, and we'll talk about that in a second, and then the square root of 7 squared. So 6 squared, which of course means 6 times 6, squaring a number means you're multiplying it by itself, is 36. Now what about I squared? Remember we already said that I, let's do it like this. We said that wherever we have square root of negative 1, we're going to substitute I. But let's square both sides. And so that we do have an I squared. And remember, when we have an exponent of 2, we're squaring a number, and a square root, those cancel out. And so we're just left with the negative 1. So wherever we see an I squared, we're going to substitute in negative 1. So I squared, we have negative 1. And then finally here, the square root and the squaring, square root and the exponent cancel out, and we're just left with the 7. Lastly, we're going to multiply. 36 times negative 1 is negative 36. And then negative 36 times 7, just checking it here, gives us 252. And of course, a negative times a positive gives us a negative. So our answer there, negative 252. All right, so those are the examples for lesson 3.1. Good luck with the work. Remember, pause, rewind, as we always say, as needed. And we'll see you in the next video. And take care. God bless. And good luck. Again, good luck with the work.